In this section, we're going to be discussing migrating virtual resources. As you'll find out, one of the first steps in adopting cloud computing is to take servers that already exist and migrate them into a virtual or cloud environment. Because typically, IT organizers and providers do not want to reinvent the wheel. There's no need to completely recreate virtual machines and the applications that they host. And so instead of starting an environment from scratch, we'll take current systems and we'll take data and we'll migrate it into the cloud. As you'll see, there are a few ways to do that. Virtual machine templates can provide standardized configuration for upcoming virtual machines. Physical to virtual migration, as well as virtual to virtual migration, are also provided. And then once virtual machines are created, we'll even have the ability to clone virtual machines. So a number of different options that we'll discuss as in the scenario in which they're warranted. So now that we understand how cloud computing benefits from virtualization, it's important to know how to migrate the organization's current environment to either a virtual environment or a cloud environment. Technically, this is one of the first steps in adopting cloud computing, is we have to migrate to a virtual or cloud environment. And when we distinguish between those two, really it's private versus public. If we are on a physical data center, we have to migrate to virtual before we can migrate to a cloud environment. But in any case, I mean, an organization is dealing with an existing situation. There's no need to reinvent the wheel. We don't need to start an environment from scratch. Instead, we want to take our current systems and data and we want to migrate that to a cloud environment, okay? And that's pretty easy to do because with the advancements in virtualization, the advancements of consolidated infrastructures, the organizations are now kind of seeing IT resources as a pool of resources that can be managed centrally, not as just one resource. And so IT administrators have the ability to move resources very easily from server to server, from data center to data center, from physical to virtual, and even virtual to virtual, and then private to public cloud provider. And so, it's very advantageous to be able to take the existing resources and move them there while getting the advantage of the cloud, the ability to balance resources and compute loads in a more efficient, even global type environment. So, and another very important and final concept that we need to discuss. So when an organization is migrating their environment to the cloud, it's important for them to have a standardized installation policy or profile for all the virtual servers. And virtual machine templates can provide that ability. It's going to include a base installation. That base installation is going to have the operating system. It's going to have certain service pack levels. It's going to have security patches installed. It might even provide standardized roles, firewall configurations, those kinds of things. When you think about that, that is set up as a virtual machine template, and it provides a streamlined approach to deploying a fully configured base server image or application server image. To a certain extent, virtual machines may be used to provide a standardized configuration for the host systems so that you can deploy hypervisors rapidly and do so to bare metal systems. Software products like System Center's Virtual Machine Manager, Microsoft's private cloud configuration tool, does require that or contain that ability. Create this template, we standardize the hardware, we standardize the operating system configuration, we push it out. Why does it need to be standardized? It needs to be standardized because many of these systems are operating in a failover cluster environment. Think high availability. I have to have the ability for a virtual machine to move from one system to the next. If I don't have that, then I lack the dynamic nature of the cloud. So since I have it, then we need to make sure that the host systems are identical because we can have problems. So it decreases installation and configuration costs because once the template is there, it can be very rapidly deployed. It cuts down operational costs because we have fewer problems of systems being moved to a hypervisor that can't support it. It doesn't provide some particular device. And so the use of virtual machine templates is going to be highly advantageous because it eliminates those kinds of situations. Now, when we talk about migrating virtual resources, we are immediately thinking of migrating my data. Now, the very first thing that has to happen is the hypervisors have to actually be created, and so that's where your virtual machine templates come in. But organizations may be thinking more virtual machine templates after the fact, deploying a certain resource, for them. Okay, and those may be pre-configured. Those would be configured by the cloud provider in many cases. It's only in a private cloud environment that I'm managing it myself. The physical to virtual type of migration is fairly easy to contemplate based on the name. It converts a physical server into virtual machine files. Those virtual machine files that can then be hosted in the cloud. It is going to migrate the physical operating system. It's going to migrate applications, and it's going to migrate data. It essentially takes all of those and puts them into a virtual machine. There's a few different ways to convert a physical server to a virtual server. One would be manual. You can manually create a new virtual machine on the host. Then you could copy all the files from the operating system, the application, the data. Obviously, that's going to be fairly time-consuming. It's not very effective. And so we're probably not going to use that. There's a semi-automated physical to virtual approach that would use a software tool to assist in the migration. Okay, that's definitely going to simplify the process. It's going to give the administrator some guidance when doing this. There are free software tools, and then there are also tools that come with larger products. So I had mentioned VMM, your ESX servers. They have the ability to automatically do this conversion. But there are also freebie utilities if you happen to be doing it in a desktop environment. Another type of migration is the virtual to virtual migration. Virtual to virtual is migrating the operating system data applications, but just from one VM to another. This is always going to use tools to fully automate the process. And this is predominantly used to convert between virtualization platforms. So, System Center VMM, sorry, I keep mentioning that. That happens to be the one that I've done the most work with, but SCVMM has that ability, has a V2V conversion wizard, and it is specifically for, let's take all those nasty VMware VMs and let's translate them into Hyper-V VMs. And of course, VMware provides the opposite. So you just have different manufacturers of platforms, and they're going to provide the ability to migrate from the competitor to them because they would prefer that you do that. The final migration is virtual to physical, and virtual to physical is provided through the use of various tools for the purpose of converting virtual back to physical. The process is going to be a bit more complex, and it's typically not something that we will, do that often. I mean, theoretically, right? So there are certain steps. First, sysprep would need to be installed on the virtual machine. You would have to sysprep it. Now, that's part of the Windows operating system. It basically just means to wipe away any of the unique configuration options. So the computer name, the SID, those kinds of things. It's basically preparing the image to be transferred. It's going to allow hardware configuration changes. That's another thing that sysprep wipes out. It's then going to load all the drivers for the target physical server prior to migration. We would use an imaging tool like Ghost or Windows Deployment Services to facilitate the virtual to physical migration. It's not nearly as common. Okay, this would be if we've gone to the cloud and then all of a sudden we've decided, wow, we just don't want all of these benefits and capabilities. It's just too complicated and we're going to revert back. And I can see organizations potentially doing that, going to the public cloud and then coming back because it introduced too much of a learning curve and they don't want to utilize it. I can't see a whole lot of organizations going to virtualization and internal private cloud computing and then reverting. So it is going to be an uncommon situation, but one that you at least need to be familiar that it exists. Another option, and this is not, I said the final option before, but Virtual machine cloning, I guess I don't think of it in terms of migrating virtual resources, but you are migrating something from one to another. Virtual machine cloning is exactly the way that it sounds. Once again, the process of creating an exact copy of an existing virtual machine. It provides just an additional method of virtual machine creation. So if you have a virtual machine and you want to simply copy that virtual machine, you can do that. The existing virtual machine will become the parent virtual machine of the clone, but it still is a separate disk. Okay, so that's one of the considerations. The parent virtual machine. Now, once a clone is created, any changes made to the clone are not going to impact the virtual machine and vice versa. All right, so you have to specify a parent virtual machine. It gets its configuration from that, but now we're two different systems. So virtual machines clone is going to have a unique MAC address, and it's also going to have a universally unique identifier that's different from the parent virtual machine. They can use shared virtual disk, but can also just use shared storage. Now, virtual machine cloning would actually take a couple of extra steps if you wanted to use it in a production environment. And we had mentioned having to sysprep. Well, I would have to do that if I truly am cloning two systems, let's say with the Windows operating system, I have to wipe that system. It could be used to deploy a baseline configuration. It often is not. Where virtual machine cloning is often used is in testing and development environments, or situations where you have an established baseline that's just required. You know, that's where you can clone that multiple times. This is your baseline configuration. But in those cases, you would sysprep it. The only time you wouldn't sysprep it is if you were setting up a non-production testbed environment for test scripts and you truly were trying to duplicate a virtual machine. So we've always got to think about this from the perspective of the host as well as the perspective of the guest operating system. Just to see, that'll help identify some of the steps that I have to take. But virtual machine cloning is another option that we have for migrating existing resources, current resources, to a new type of environment. Another option for migration is migrating storage, simply the process of transferring data between storage devices. It can be automated or it can be done manually, but storage migration is going to make it possible to migrate a virtual machine's storage or its individual hard disk to a new location while maintaining continuous availability. So typically it will eliminate any service disruptions because the virtual machine can be accessed while it's being migrated. Its data can be accessed because it's on shared storage. So we have this ability to move virtual machines to a new location, and while moving it to a different storage array, we can still access it. So it is very beneficial being able to migrate storage. They often will call them live migrations because we are migrating the current state of a virtual machine and its storage and moving it to that different array. It also provides the ability to prioritize storage based on current virtual machine requirements. So we can use the concept of tiering, where the virtual machines that are have the heaviest disk I/O can be moved to the higher speed drives and provide that increased performance. All right, let's talk about some considerations for migration. You need to, as we're migrating virtual machines, specifically in a virtual to cloud environment, but more so when I'm actually in charge of the resources, the compute resources need to be adequate on that destination system. I can't automatically or manually migrate a virtual machine if the destination system is unable to handle the load that we're putting on it. And if I'm not careful and I don't plan it out, then I can have sort of disastrous consequences down the road. So we begin by Just gathering requirements, look at the physical servers in the virtual environment, identify which servers we're going to migrate first, identify which servers are good migration candidates. Okay? Is a physical server a candidate for a virtual server? How do we figure that out? Well, we have to monitor them over a period of time because that's going to give us sort of an accurate profile of the server, of its workload, so that I can calculate the compute resources, right? Microsoft's Performance Monitor, there are other comparable options in Linux environments that they can give me an accurate assessment of the resource usage for that particular server. So we do need to make sure it's over periods of time, and we would use utilities that we're familiar with to identify not only the current needs, but try to analyze trends, peak times, and those kinds of things. Another consideration to make to determine if a physical server is a good candidate for virtualization is the status of the file system. Okay, what do we mean by that? Well, when you convert from physical to virtual, all the data is copied to the virtual server as a part of that physical to virtual process. And files and data are sometimes kept on servers that aren't required. They once were required, but they're no longer required. So essentially, take a look at the hard drive of the physical server before we do any migration. Make sure we've gotten rid of old files, unnecessary files. Make sure we've done a good defragmentation, in order to get it ready. Some more considerations for migration would be maintenance scheduling. So after we've gathered all the information, we know we're ready to go and think we can perform a successful physical to virtual migration, we need to plan when it's actually going to be completed. Okay. Downtime is going to be expected during some server migrations, at least initially, into the cloud. And so we need to adequately plan for this. The maintenance schedules can be created or can be implemented when planning this out. And if you need to consult change management teams, then we can do so. As for upgrading, you have the option of upgrading existing virtual machines to the latest virtual hardware or host operating system. That's something that comes along with migration. If we would upgrade to the newest host systems, we want to upgrade the guest tools as well so that we are able to get all the features. And then finally, we would want to do some testing. There are testing considerations. When you are trying to migrate from physical to virtual, virtual to virtual, we may want to perform some tests before we migrate our actual physical servers, because it can actually leave the system less than functional in some cases. That's unlikely. It's uncommon. I mean, generally speaking, it will leave the entire system that's migrated intact. But with that said, I mean, any system that's being migrated should be tested before we actually do a migration. So these are just some additional considerations for migration. Hopefully they'll help us to be able to successfully deploy virtualized cloud environments. In this section, we learned about migrating virtual resources because as IT providers, we don't want to reinvent the wheel. There's no need to recreate operating systems and applications. Instead, we can migrate existing resources and data. The most common migration would be a physical to virtual migration, where we're taking physical data centers and turning them into virtualized data centers. We also, though, have options of virtual to virtual if we're changing platforms from, say, ESX server on VMware to Hyper-V. And we even have the uncommon virtual to physical if we actually need to switch back to the physical data center. We discussed the situations in which all of these were used, as well as a couple of other options, virtual machine templates and virtual machine cloning, which will very quickly allow us to duplicate virtual machines, as is sometimes required in a cloud environment.